let's graph a couple of different logarithmic functions. We're also going to give their domain and range using interval notation. Let's do part A. First thing I'm going to do is actually begin to identify some of the transformations from your base function. So your base function here is actually b of x is equal to, let's say, log base 2 of x. Clearly, right here, this says we're going to move our base function 3 units to the right. And then the later transformation says, take that part there, and that says move your y values down 1 unit. So with that being known, we are ready to graph this. Another way to handle graphing is actually pick ordered pairs. So we're going to do a combination of both. We're going to do transformations and we're going to do ordered pairs. So let's do part A. Let's do a t-chart. X and f of x. Notice the domain here, x minus 3, has to be greater than 0. So the only x values you could pick are actually more than 3. So the first x value I'm going to pick is actually 4. Because when you find f of 4 is equal to negative 1 plus log base 2 of 1, or 4 minus 3. 4 minus 3 is 1. So log base 2 of 1 is 0. So this is negative 1 plus 0, which equals negative 1. So we get a value there. Another good x value to pick here would be, let's see, 4. It would be nice to get 1/2. So 3.5? 3.5 would be good. So what's 3.5 as a mixed fraction? 7/2. So if you pick x to be 7/2, we equal negative 1 plus log base 2 of 1/2. 1/2 is just 2 to the negative 1. And so that's just negative 1 minus 1, which equals negative 2. The cool thing about log properties is a lot of times you don't even need your calculator. Another good x value to pick would be 7, right? So if you pick 7 here, we get log negative 1 plus log base 2 of 4. And so eventually you simplify and get positive 1. I'll leave it up to you to write out those details. With the transformation, we also need to identify something very, very important, and that is going to be called a vertical asymptote. So make sure you're able to identify the vertical asymptote. Vertical asymptote, I'm going to actually write this in a different color. Vertical asymptote. Let's try this color. So let's make sure we have a vertical asymptote. I'm going to make some space here. Our vertical asymptote is x equals 3. I'm going to clear this out. give myself more room to graph. And for graphing, use graph paper and a straight edge. Those always come in handy. Looks like so there's your y-axis. For -1, ordered pair 4, -1, right here. Let's use red. 3 1/2 is -2. And I forgot something really, really important. We should draw our what? Draw our vertical asymptote first. There we go. That makes things a lot easier. At 3 1/2, it's at -2. So let's put a -2 here. This was a 4. And then at 7, it's going to be at 1. Right here. And now, this does look like the inverse function of an exponential function. Whoa, that's cool. We got a log function. We need to specify its domain and range. Let's find that. The domain of f. Once you have graphed it, it's actually pretty easy to identify all our possible x values. We actually found them right here. So parentheses 3, and then go to the concept of infinity. Now the range, remember you're reading from top to bottom, the range of f is equal to, we're reading bottom to top. Bottom to top. So if you're reading the y values from bottom to top, here are the y values, there's an arrow here to indicate the range. So you're really starting with the concept of negative infinity and then work your way what? Your y values are constantly going up because of this arrow here. So it's negative infinity to positive infinity. Let's write that. There you go. How do you show work for graphing? Well, label your ordered pairs, label your vertical asymptote, write your domain and range, and of course, graph neatly if you can. Use your own graph paper or write your own graph paper. Let's label our vertical asymptote. And let's circle all our work as well. And so that is the answer for part A. Feel free to do part B. All right, let's try part B. Part B, we have a g of x. I'm going to approach it the same way. We're going to look for its domain. So the domain of g. If you look at this, notice it says x plus 1 has to be greater than 0. So x has to be greater than -1. I said -1. Why did I write that? This also helps you identify your vertical asymptote. Vertical asymptote is going to be x equals -1. Now the only thing left to do is plot some ordered pairs. We have base 2, so why don't we pick x to be 0? And if you do that, we get 3. Pick x to be 1. Pick x to be 1, we get 3 plus 1, which is 4. Now you might think, oh, why don't we pick x to be 2? Now you don't want to do that. The next number you want to pick is 3. X to be 3, and then we get 5. Okay, what's the next number you would pick? You would actually pick 7. And if you pick 7, we get 6. Cool patterns. Let's plot this. Let's bring out our straight edge again. Looks like I have mostly quadrant 1 values. So I'm going to put more emphasis on quadrant 1 here. So after you graph your axes, go ahead and plot your vertical asymptote. So right here, this is 5. In case you're wondering, this is 3. We have 7, so this is 3 as well. This is 6, and 7, 6, right here. And you draw on your vertical asymptote. You have enough dots, connect them. This approaches down like this, never crosses the vertical asymptote. And so there is your graph. The only thing left to find is your range. Let's find the range. Let's write the domain again. Domain of G is equal to -1 to infinity. And the range of G, reading from bottom to top, -infinity to infinity. All right, we got everything here. Everything is labeled. Vertical asymptote is labeled. So let's circle all the work and the answers that are necessary. Ordered pairs are labeled. Now let's do a better circle. And we're done.